All right, let's go. We don't got much time. In Pix 2048 data section, we have a dirty flag optimization data section. We have two major partitions. Is it part of the DOM or is it not part of the DOM? This is miscellaneous memory. This is the tile map memory, that 3x3 grid of level packs. Let's take a look at the diagram right now. So this diagram right here, these are our 3x3 grid of level packs where all of our tile data is. This is miscellaneous data for like player, state, position, etc. We haven't allocated it yet for anything. These are the master memory index enumerations that correspond to this diagram over here. So these are analogous diagrams. Okay, let's go back to where we were earlier. Okay, so let's say that we set a tile in the middle level pack in the middle level pack. Well, first of all, this will end up being a non-zero value. Then this value in here is going to end up non-zero because this is our 3x3 grid of level packs, and these are all bit flags. These are 16-bit flags, right? So one of the bits in this flag is going to get set to 1, right? And so we're going to iterate through all of this, and then once we get to here, we're like, hey, this one right here, you're non-zero. You must have something in there. So then what we're going to do is we're going to find the correct bit in here corresponding to the level of the level pack. So this whole number right here represents all the flags in one level pack, right? And these are all the level packs, are 3x3 grid of level packs. So anyways, this one bit in here is going to get set. We're going to find that one bit and know which level has the dirty tile in it. Then we're going to use that bit index to grab the correct dirty rectangle from this dirty rectangle array. There are 256 dirty rectangles because each level requires a 128 by 128 subsection of pixels in order to encode all of the level data. We are going to overlay a uniform grid of dirty rectangles to cover the entire surface of the entire master memory. It's going to take 256 dirty rectangles to cover the entire master memory if a dirty rectangle can only get as big as 128 by 128. We also need 4 pieces of data for each dirty rectangle: the X bounds and the Y bounds, so the left, right, top, and bottom. Going down further, here's what we did previously, and we're out of fucking time. I can't describe all this other stuff. You're going to have to go to the longer video if you want to see more explanation. More explanations here. We got to go before we're out of time. I'm out of here. Bye.